Let's use the graph of y equals f of x to solve this exercise. We have several parts. In part A, we want to answer the question, what is f of 4 minus f of negative 3? And I'll actually do that part up here. F of 4 minus f of negative 3. Well, f of 4 really means we're looking for the y value or the function value when x is equal to 4. So f of 4 we can find on this graph by going to find when x is 4, and let's look and find the function value. And we can see the function value right there has a y value of 3. So f of 4 is equal to 3 minus, again, we need to calculate f of negative 3 by looking at the graph. F of negative 3 really means what is the function value or the y value when x is negative 3. Well, let's look on the graph. When x is negative 3, go down to the graph, find the y value, and the y value we can see is negative 2. So we have 3 plus 2, or 5. So we can say f of 4 minus f of negative 3 is equal to 5. What is the domain of f? Remember, in part B, the domain is simply any x values that can be inputs for the graph. Well, let's look. The very lowest x value that I have, the furthest to the left on the graph, is really almost until I get to negative 5. Because if I look up on the graph, there's an open circle at negative 5. So x does not actually take on the value of negative 5. So we're going to use an open interval for negative 5, meaning the graph does not include an x value of negative 5. If we go all the way to the right, the largest x value that could possibly be would be 6, because notice 6 comma negative 3 would be the farthest value to the right that this graph takes on. So the furthest to the right the x value goes is 6, and it includes 6 because it's a closed circle, so we use a bracket. Now in part C, what is the range of f? The range are the y values. We can find the range by taking a horizontal line starting at the bottom of the graph and going up and see what values are covered in terms of y. Well, the lowest y value we can see is negative 4. It includes that point, so we'll use a bracket. And the highest y value that we can see is positive 5, and it also includes that value, so again we use a bracket. Let's move on to part D. In D, we want to know on which interval or intervals is f increasing. We can see that f is increasing anytime we move to the right and the function values are getting larger. So notice down here, we seem to have a low point right here, and then as we move to the right, we get higher and higher y values until right about here. So whenever we look at intervals, we want to consider x values. So for D, we want to look at the x values where this function is increasing. Well, right down here, this looks like it has an x value of negative 1. So for increasing or decreasing intervals, we always use open intervals. So x is going from negative 1 all the way, looks like it stops increasing right about there, so that has an x value of 2. So on the interval from negative 1 to 2, that open interval, we can say that f is increasing. Now on part E, we want to look at the interval or intervals where f is decreasing. Again, we're looking at x values, and if the function f is decreasing, that means the function values are getting smaller, the y values are getting smaller as we move to the right. So we can see that when x is negative 5, all the way until right down here when x took on a value of negative 1, it appears that this function was decreasing. Also, we can do a union. It's decreasing on another interval. It looks like right here when the x value is 2, all the way till the end of the graph when the x value we see is 6. So it's decreasing on those two open intervals. So for part F, we want to know for what number does f have a relative maximum and what is the relative maximum. By looking at the graph, the points at which the function changes from increasing or decreasing behavior tell us where the maximum or minimum values are. So a maximum seems to occur right about here when the x value is 2. So when x equals 2, it appears to have a relative maximum because it's changing from increasing to decreasing. And what is the relative maximum? Well, that's the y value. The relative maximum is equal to the y value of 5. Let's move on to part G. In part G, we want to know for what number does f have a relative minimum and what is the relative minimum. Remember, anytime the behavior changes from increasing to decreasing or decreasing to increasing, we have either a relative minimum or maximum. And it looks like right about here we have a relative minimum. So in part G, the x value that corresponds to that relative minimum would be an x value of -1, and that relative minimum would be f of -1, or a y value of -4. In part H, what are the x-intercepts? Well, the x-intercepts are any time the graph crosses the x-axis. And we have 3 x-intercepts. Those 3 points are -4, 0, 1, 0, and also 5, 0. It's important to notice anytime you have an x-intercept, the y value is 0. In I, what is the y-intercept? The y-intercept occurs anytime the graph crosses the y-axis. Here we have a y-intercept at -3, so we can say the y-intercept is 0, -3. Also notice that anytime you have a y-intercept, the x value is equal to 0.